Okay, dear students, so today we will discuss about the maximization case of transportation problem. Okay, so till now we were discussing about minimum cost, like basically what is a transportation problem. In transportation problem we are trying to find out the minimum cost of transporting one material from the source to destination. But now today we will discuss about the maximization case of transportation problem. So in such a problem you will be given a profit matrix. So here we are going to find out what is the maximum profit that we can gain or that supplier can gain by transporting a particular material from a source to a particular destination. Okay, what is the maximum profit that he can make? That means when the cost, there the cost will be minimum, but with that minimum cost he is trying to maximize the profit. Okay, now you consider this particular problem. Obtain the initial basic feasible solution of a transportation problem whose profit matrix is given below using Vogel's approximation method. Okay, now since in this question they have asked that you have to use Vogel's approximation method, you have to use that method. But otherwise, if it is only just initial basic feasible solution, you can use any method, that is either northwest corner rule, least cost method, or Vogel's approximation method. Okay, so today we will discuss how we can do a maximization problem using VAM. Fine. Now this is the question. A profit matrix is given where you have three destination or three markets M1, M2, M3, and you have two sources or stores, that is S1 and S2. The demand is given and the supply is given. Okay. Now first thing that you have to do in case of any transportation problem is to check whether it is a balanced problem or not. Okay. Now 25 plus 20 will give you 45. 18 plus 16 plus 11 will give you 45, which means that this is a balanced transportation problem. Okay, now that is clear. So now this is a balanced problem. Here you have what supply is equal to demand. Fine. Now this is the given one. The given problem is a profit matrix. Okay, so what does this mean? That means here if you take, this is S1, for transporting some material from source 1 or S1 to market M1, the profit incurred is 4. 4 can be rupees, so it is rupees 4. Okay, that is the meaning. Okay, that is profit that a company gets when material is transported from S1 to M1 is 4. Okay, now in order to solve this problem, you have to convert the profit matrix to cost matrix. Okay, so in order to convert a profit matrix to cost matrix, what you need to do is you have to first check for which is the maximum profit. Now if you consider this particular matrix, you can see that 9 is the maximum value. See, this is 4, 4, 9, 3, 5 and 8. So 9 is our maximum value. So that means you have to subtract all other values from 9 in order to get the cost matrix. That means in the first case, this will be 9 minus 4, 9 minus 4, 9 minus 9, 9 minus 3, 9 minus 5 and 9 minus 8. Okay, so you will get the cost matrix. No, so now we will write our cost matrix. The first one is 9 minus 4, which is equal to how much? 5. Then again 9 minus, the second one is also 9 minus 4. So 9 minus 4 again, which is equal to 5. And here it is 9 minus 9, which is equal to 0. Then you have 9 minus 3, which is equal to 6. 9 minus 5, which is equal to 4. And 9 minus 8, which is equal to 1. So this is the value for, these are the values for cost matrix: 5, 5, 0, 6, 4 and 1. That will be our cost matrix. Okay, so you can rewrite the cost matrix like this: 5, 5, 0, 6, 4, 1. Now I have solved this particular problem using VAM. Now I have already explained to you in the previous video how to solve a particular transportation problem using VAM method. The only thing is, first you have to draw the matrix. Okay, we have the new matrix 5, 5, 0, 6, 4, 1. Then you will have to draw the row difference. You will have to write row difference and column difference. What is row difference? That is, you have to select the smallest value. Here it is 0 and then the smallest value is 5. Okay, so 5 minus 0 you will get 5, right? Here again 1 is the smallest element and 4 is the next smallest element. 4 minus 1 will give you 3. Similarly, you have to solve the whole matrix. Okay, so using VAM you will get different allocations at the end. So here you have different allocations. How are the allocations? In S1 and M1, after solving you will get in S1 and M1 you have 14. Okay, allocation number 1. Then the second allocation is in S1 M3. S1 M3 you have the second allocation. Next will be in S1 M1 4. S2 M1, then S2 M2. So you have all this 4 allocations. So you have to write down these are the allocations. Now the same allocation is what we are going to write for the profit matrix also, because you have to remember that this is not a minimization problem, this is a maximization problem. We started with our profit matrix, right? We started with this matrix. This is our profit matrix or the initial matrix. So the same allocations, whatever we got here, we have to allocate in the similar manner in this particular matrix. So how we will allocate? So this is our profit matrix. Fine. So what are the allocations? You just see. The first allocation was in S1 M1. That is the first column. So first S1 M1, our allocation is 14. Fine. So you have to write 14. Then in S1 M3 it is 11. S1 M3 it is 11. Okay. Then the next allocation is S2 M1 and S2 M2. S2 M1 is 4. S2 M1 you have the allocation as 4. Then S2 M2 is 16. S2 M2 you have 60. Fine. So now you have the allocation for the profit matrix, correct? So when you have allocation for profit matrix, what you need to do, it is simple. We can find the basic feasible solution. How do we find the basic feasible solution? You have to just multiply 14 into 4 plus 11 into 9 plus 4 into 3 plus 16 into 5. Clear? So finally you will get the answer as 247. Okay, rupees 247 is your basic feasible solution. That is the basic profit. In the basic feasible solution, the profit is 247 rupees. Okay. So if it is if they are asking you to optimize the solution, we will have to optimize the solution using Modi method. As of now, the basic feasible solution for this maximization problem is 247. Okay. Thank you.